slope. So I heard rise over run. So if I have, thank you. You don't want to hear me just talk and not see what I'm doing? There we go. All right, so if I have a line, I can count my rise and then my run. And linear means it's constant, right? Rise, let's say 2, 3. 2, 3. What else do you remember about slope? That's the easiest one, right? Rise over run?
Yeah.
How about, we've got positive slope, right? We've got, what's this one? Negative slope. What's this one? What? Wasn't what I was looking for with slope, but I can see what you're trying to say. 4 different types of slope. This one is positive. This one is negative. This one is, oh, sounds like there's some kids that haven't seen Slope Dude, right? Because once you've seen Slope Dude, you'll never forget. Now, do you remember?
You'll find out. Well, something with the boy and the girl, right?
No, I can. Let's pause this. I'll show you.
Welcome to the Adventures of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him. He'll teach us some important aspects of slope. This, of course, he's skiing today. What he says will teach us about slope. Always remember that Slope Dude always skis toward the right or eastward. When he starts out, it's going uphill. It's hard work. He says up, up, positive as he goes up the mountainside. Up, up, positive. Up, up, positive. Now he's at the top. He goes up, up, positive, all the way up the mountain. But now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative, nice, negative. And now, back to the downhill, he's in for the hardest part of the ski route, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. As he finishes the flat part, he doesn't see well ahead, and all of a sudden he comes to the edge of a cliff. It's straight down. He finds a slope that's straight down, and so frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the adventure of Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and straight down, he yelled the worst curse word of math and algebra. Undefined. The uphill is the slope with a positive number, the downhill is the slope with a negative number. The flat part is the slope of 0, and the straight up and down or vertical part is undefined. This has been the Adventures of Slope Dude. Special thanks to King Uni for inventing Slope Dude. Thanks for being here.
Never forget now, right?
I wish I could.
You wish you could. That this is undefined, correct? Right? And this is zero fun, right? Okay. Alright, let's move on. So I'll put this in the presentation for you guys, just in case you forget. I've always said I was going to be Slope Dude for Halloween. Never done it. Alright, students will be able to analyze linear functions. Find and use the slope of a line and graph parallel and perpendicular lines. So this is all review, and most of you are pretty good with slopes, right? So this should be pretty painless. All right, that's why you've got two different pages that you're doing today, but I still did cut homework quite a bit. A linear function, a function whose ordered pairs satisfy a linear equation, can be written in the form of f of x equals mx plus b, or y equals mx plus b. So we're going to talk a lot about y equals mx plus b. So, which ones are linear functions and which ones are not? What about, let's see, put this stuff up here, this one. That one a linear function. Should we start something easier? What about this one? What about this one? Is that linear? Yes, that one's linear, right? The slope is half as steep as it normally is, right? Here's the other slope, so it would be like half as steep, right? Okay, so what about this one? X equals 9. No? You guys don't think so? X equals 9, the vertical line. Alright? You thought what? It is, but undefined is, it's still linear. Linear means in a straight line. Got it? Nonlinear means not in a straight line, linear means in a straight line. So it's an undefined slope, but still linear. Make sense? Okay. See, that's why we do this, because it's like a type of compare and contrast kind of exercise. Not this one.
No.
Is S's and T's unacceptable? It's just not. What if I changed it to this? Couldn't I just divide everything by 6? And then it's a y equals? So is it linear? What's not linear? Without even looking at what we've got down here, do you guys know what wouldn't be linear?
That's y equals
Without using these down here, just tell me what would not be linear.
y equals x squared.
Y equals x squared. Okay, that's a parabola. That's not linear. So does any of these mimic that? No, none of them? Yeah, one of them's quadratic right here. That right there. Anybody else know something that's not linear? The one with the square root. Does anybody know what a square root function looks like on a graph? It looks like that. Okay, so we'll get into that this year, for sure. Alright, what else? This one looks kind of funky. Y equals 1 over x. Y equals 1 over x is not y equals x. It's like when x becomes in the denominator, it looks something like this. Okay? That's this one. What would happen with this one? This one's a little bit harder. Let's leave this one here. I don't even like this one. I don't. What about this one?
Yeah.
Why? Could you put it into y equals mx plus b? Yes. This is actually in standard form. It can be put into y equals mx plus b. Okay, let's move on. All right, write an equation in standard form. Identify A, B, and C. So I'm going to take this and I'm going to turn it into what this last one was right here. Okay, because that's what this is called standard form. Standard form, this would be AX plus BY equals C. So in this one, what's A? And what's B? And what's C? Perfect. All right, so write an equation in standard form, identify A, B, and C. So apply a strategy to convert into standard form. So I know my strategy is I need to get the x's and y's on one side and constants on the other. I've got a constant here, so what do I need to move? I need to move the 2/3 x. I don't want to deal with a fraction, because that's not what standard form looks like. Does anybody know how we can clear that fraction? Multiply everybody by 3. So if I multiplied everybody on this side by 3 and everybody on this side by 3, I could clear my fraction. So that would result in 3y equals, when I distribute this 3 to this, what happens to my fraction? It turns into 2x. And when I distribute the 3 to this one, it becomes positive 3. Now we're getting closer to standard form. So all I have to do now is subtract both sides by 2x. Now, didn't turn blue. So now I have negative 2x plus 3y equals 3. What's wrong? No, you're right. What's wrong? It's a negative. Okay, so I want to talk about this for a second. What's the big deal? It's negative. We moved it over. Why am I having a fit about it? X always, whatever's in front of x, that always controls your slope. Right? It's like x is in charge. X is the input, y is the output, right? So if x is the input, we really have to concentrate on x. You can't turn 2x into a negative, because now, if you look at that and I ask you, hey, what's the slope of this line, without doing anything, you'd say, oh, it's a negative slope, because I've got negative 2 out in front of that x. Correct? So you have to be really careful about that. So how could I change this so that this is not negative 2x anymore? What did you say? Okay. Basically, you guys are saying the same thing. Multiply or divide everything by negative 1 is what you need to do, right? So if I want the opposite of 2x, couldn't I make everything opposite? So that would be opposite. This would now be negative, and this would now be negative. As long as I do it to everybody, I'm safe, right? Correct? That's the rule in algebra. As long as you do it to everybody, you're okay, because we've got an equal sign here. What would be another what could be another strategy? What could I have done in the very beginning that would have avoided that? In this step here, I could have said, that's locked down. We do not want to mess with this guy right here, because he has to stay the same. If he's positive now, he needs to stay positive. If he's negative, he needs to stay negative. So I could have moved my 3y over here and my 3 over there. So it's just your decision what you want to do. They both have the equal amount of steps, right? This one you have to do 2 steps when I subtract 3y and subtract 3 from both sides, correct? But then everything's where it's supposed to be. This one, I only have to move one thing, but I have to change everybody's sign. So I'm going to move this. Let's just take a picture of it. And make it smaller. This. Which one do you guys like better? Going to the right? Shade them in different colors. I'll just move it over a little bit. Is that a little bit better? Alright. So now if I finish this one up, I would have negative 3 equals 2x minus 3y. Is that the same thing I have over here? Yes. I missed something? Here. All right, guys, write that down. Make sure you have it all down. I'm going to rewrite this. You don't have to write both instances if you don't want. So this is negative 2x plus 3y equals 3, and I'm going to change it to 2x minus 3y equals negative 3. Do 1. All right, here's the second example that I'd like you to have for your homework. Find the x-intercept and the y-intercept of the graph, then graph the equation. All right, so an x-intercept means that you've got, I know what x is when y is 0. And a y-intercept is exactly opposite, right? I know what y is when x is 0. Correct? Intercepting the x-axis, if something intercepts the x-axis, see how it's nothing on y? Its value is 0 on y? How do I get here? What's that point? 1, 2, 3, 4, 5, 6, 7. Isn't that negative 7, 0? Y is 0. So if I wanted to make my y-intercept, this would be 1, 2, 3, 4, 5, let's say 6. What would that plot be? 0, 6. So see what I mean? So let's do this color coordinated. How come? I need to do some update or something because it's giving me a hard time. All right, so let's start off with the x-intercept. So in order to find my x-intercept, what am I going to do with that y? What? Well, what does this say? What is y? What's the value of y when we have the x-intercept? You can cover it with your hand, or you can just make it 0. 0 equals negative 5x plus 3. Now what would I do? Subtract 3 from both sides. So I would have negative 3 equals negative 5x. Then what would I do? Divide by negative 5, which gives me x equals 3 over 5. 3/5 is a little over half. So my x-intercept would be right, I don't know, there. Let's do the y-intercept. So my y-intercept is, I need to find y when x is 0. So I do the same thing. Y equals negative 5 times 0 plus 3. Well, what happens when negative 5 is multiplied by 0? It just becomes 0. Y-intercept's actually a lot easier. Y equals 3. So my two intercepts are 3/5 0 and 3, 0. So 1, 2, 3. So if I were to plot this line, I could do it with just the intercept. With something just like that. Question? Yes, sir. You're absolutely right. Thank you. 0, 3. Thank you. All right, copy that down. We forgot to identify A, B, and C. So my A is 2. My B is negative 3. And my C is also negative 3. So you see how you would be wrong if you were to say A was negative 2? A is never going to be negative. Sorry, I shouldn't say that. It could be negative, it could be negative slope, right?
Well,
All right. Is everybody finished copying this down? Another minute or so? Okay, recording again. We'll skip over that one. All right, slope, a rate of change that measures how much a quantity changes relative to change in another quantity. So we talk about it's a ratio, right? So I'm talking about the change in y compared to the change in x. We call the change in y, the shortcut for writing the change in y is delta y, where delta means change. We'll put that over here. Delta equals change. So it's change in y over my change in x. How much do I rise compared to how much do I run? That's what slope is. So this one is, describe these slopes for me. This one is, class, positive, and this one is zero fun, right? And this one is negative, and this one is undefined, right? Okay. Talk to me about parallel lines. What does a parallel line look like? Show me with your hands. What's a parallel line look like? Yeah? When you're doing this, right? What characteristic do we have about parallel lines that tells us they're parallel? What? They never touch. Perfect. They never touch. What about their slope? Not the opposite, because slope would mean the rate at which it's rising, right? Rising compared to how much it's running. So if I have a parallel line right here, we'll draw one right on top of there. It's parallel means it's just either above it or below it, right? So what do I see about that slope? They have the same slope. So parallel lines are the same. Slopes are the same. Okay, I've got a really nice way to remind you about perpendicular lines. So perpendicular lines is the other one. So check this out. Tell me what happens with this line as I make it perpendicular. So first I'm taking it and it's positive now, right? You guys ever see this? My black line right here is positive. So what happens, what did I do it if I flip it this way? Now what is it? Is that a perpendicular line? It is? Does it look perpendicular? They're crossing, does it look perpendicular? What's perpendicular mean? It forms 90 degrees, right? Does that look like it's forming 90 degrees? No. So not only, so let's say the slope of this line was, I don't know, up to over 3. Let's just pretend its slope is up to over 3. So perpendicular, if I were to switch the slope in the negative direction, that would be negative 2 over 3. But that didn't do enough for me. Instead of going up 2 over 3, if I make this line go up 3 over 2, that's what makes it perpendicular. See that? So I switched it. Instead of rising 2 and running 3, we're going to rise 3 and run 2. That's what makes it perpendicular. So not only, so if your line's like this, not only do you have to switch it to a negative direction, but you also have to switch the steepness. You see what I'm saying? Make sense? So slopes of perpendicular lines are negative reciprocals. So let's practice that. So what's the negative reciprocal of 4 over 3? Negative 3 over 4. Good. What's the negative reciprocal of 1/2? negative 2 over 1, or negative 2, right? What's the negative reciprocal of 4? Negative 1 over 4. I think you guys got it, right? So not only are you taking the opposite, you're also taking the opposite slope. You're flipping the rise and the run. You're exchanging them. Fantastic. Okay, make sure you have some part of this information into your notes. You don't have time. All right, so find the slope of the line that passes through each pair of points, then graph the line. So you guys are probably used to the old formula. The change in, which one is it? The change in y first or the change in x first? Rise or run first? Rise, so the change in y compared to the change in x. And you guys are used to the whole y2 minus y1 over x2 minus x1, correct? All right. I like to look, let's look at our change in y over change in x. Let's start with our y's. How far is it on a number line to get from negative 1 to negative 3? Not negative 2. The distance, right? If I were at a number line at negative 1 right here, how far would it be to get to negative 3? 2. And let's look at our x's. How far is it from negative 2 to 2? Good. So my slope is 1/2. That's the way I do slopes. All right, let's look at this. Negative 2, negative 1 is right here, and 2, negative 3. 1, 2, 1, 2, 3. So can you tell me whether that's a positive slope or a negative slope? Negative slope. I'll do it the other way as well. Change in y over change in x. So this is our first y, this is our second y, or I should do it the other way around. First y, second y. So I would take negative 3 and negative 1 and find the difference between them. Isn't that what you're doing when you find slope? The change is the difference between them. Then I find my x's. Here's x1, here's x2. 2 and negative 2, and you find the difference between them. Isn't that confusing? A lot of negative signs, right? And when you're done with it, you're like, I hope I got that one right. Correct? You're more than welcome to do this, but I've seen so much more success with just this. Think about it. How far is it to get from negative 2 to 2? It's 4. How far is it to get from negative 1 to negative 3? It's 2. Question? All right, make sure you've got that down in your notes. Graph the line through the given point that is parallel to a line of the equation. What does parallel mean? What do we know about parallel and slope? Same. So I've got to find the slope of this line. Well, in order to find the slope, it would be useful to use slope-intercept form, correct? So let's change this into slope-intercept form. What do I need to do first? Yeah, I want to isolate that y, correct? So in order to isolate y, I need to subtract x first. So I would have negative 3y equals negative x plus 3. Can we do that in our head? Now what? Divide by negative 3. Divide by negative 3. Divide by negative 3. If I do it to everybody, I'm allowed to do it. So I'm left with y equals, this becomes positive, right? 1/3 x minus 1. So if this is the slope of this line, what's the slope of my parallel line? Parallel means same. So wouldn't it be the same? So all I was getting from this right here was the slope. So now I know my slope is 1/3. All right, so -2, 4. So here's -2, 1, 2, 3, 4, and my slope is 1/3, so up 1/3. That kind of gives me an idea of what my line should look like. All right, now, how would I go about coming up with an equation for this line? What do I need for an equation of a line? It's your favorite thing in slope. It's up here on this page. What? Well, what does the slope of a line look like? Rise of one. What is a line? What do we normally? Y equals mx plus b. I need it to look like this. Y equals mx plus b. So I need to find my slope, and I need to find my y-intercept. I already found the slope. It's 1/3, right? So what's the only thing I need? The y-intercept. How do I find a y-intercept? We did it like 3 screens ago. How do I find a y-intercept? I have an approximate right here. How do I find a y-intercept? When I want to find y, what do I do to x? Make it 0. So, if I know what y is, if I make x 0, what am I going to get on this one? Let's see. I've got a y and I've got an x. They're right here. So I'm going to substitute the question mark here. These are my least favorite, by the way. So if y is 4, my slope is 1/3. What's x? So 4 equals -2/3 plus b. This is a nasty one, huh? Can anybody do that in their head? Why would you want to? Is that what I heard? 4 2/3. How much is 4 in thirds? If you change 4, not 10, whoa, you already did the math, right? Tell me just the first part. What is 4 in thirds? What is 4 in thirds? I just heard it. There's 12 3s and 4, right? To make 4 into 12, into thirds, I would need 12, right? So 12 thirds and 2/3 makes 14 thirds. B is 14 thirds. Holy cow. That's an ugly one. I'm sorry. All right, guys, copy that.